Here we have another example, similar to matched problem 1. We want to describe the behavior of our function at each 0 of the denominator. Again, anywhere there's a 0 in the denominator, we either have a vertical asymptote or an open circle in the graph. Using limits, we want to determine what we're encountering. So in this case, x plus 3, that quantity squared, will only equal 0 if x is equal to negative 3. So what we need to consider is the limit as x approaches negative 3 of x minus 1 over x plus 3 squared. Now in this case, there's nothing to factor, there's nothing that we can cancel. Direct substitution isn't going to work because we're going to get that 0. So again, we need to consider both the right and left-hand limits. So we'll start by considering the limit as we approach negative 3 from the right-hand side of x minus 1 over x plus 3, that quantity squared. Now again, we're not saying these are equal, but informally, this is approaching negative 3 minus 1 over negative 3 plus 3 squared is going to be 0. Negative 3 plus 3 is going to be 0, and since we're squaring it, whatever value we come up with that's very, very, very close to 0 is going to be squared. So we're going to be getting closer and closer to 0, but from the positive side. So this is equal to negative 4 over 0 from the positive side. So negative 4 divided by something that's getting smaller and smaller and smaller and smaller is going to be headed to negative infinity. And again, you could try plugging that into your calculator. You could take negative 4 divided by values that are getting closer and closer to 0, 0.01, 0.000001. You could graph this function in your calculator. A couple different ways to see that behavior. Again, this is enough to say that there is a vertical asymptote at x equals negative 3. But again, we only know what's happening on one side of that asymptote. As we approach negative 3 from the right-hand side, our function is heading down to negative infinity. But what's happening as we approach from the left-hand side? So we'll consider that limit as well. So nothing changes with the numerator in this case. That's still negative 4. And the denominator, we have negative 3 plus 3, which is going to be getting closer and closer and closer and closer to 0. But since we're squaring it, we're always getting very, very close to 0, but from the positive side, which leads us to exactly the same result of negative infinity. So in this case, our right and left-hand limits are equal to each other. So we could say that the limit as x approaches negative 3 of this function f of x is equal to negative infinity. And again, in this case, we can make that statement because the right-hand limit, left-hand limits match up with each other. But again, just to keep in mind, we're stating this even though this means that the limit does not exist. The limit doesn't exist because the definition for the limit requires the limit to be a number. Infinity is not a number, it's just a concept. But if the right and left-hand limits are the same, we can write this statement. Basically, it gives us a little bit more information than saying does not exist. It tells us the specific way or the reason why that limit doesn't exist. In this case, because the function value is just plummeting down to negative infinity from both directions.